Welcome to this explainer. Today, we're decoding a pretty fascinating architectural mystery regarding error handler drift. If you've ever spent hours chasing down a system warning, only to realize your application was actually working perfectly fine the whole time, well, you are absolutely going to want to hear this.
Picture this bizarre scenario. You've got a perfectly healthy installation. Your code is clean, the server is humming along, but your diagnostic tools are suddenly screaming at you, triggering a false alarm about your error handlers. Why does this happen? And more importantly, how do we fix the underlying architecture so it never happens again?
Here is our roadmap to solve the mystery. We'll cover the false alarm problem, define handler drift, look at the naming mismatch bug, aggressive error grabbing, the provider seam solution, and finally, restoring the honest contract.
Let's kick things off with Section 1, the false alarm problem. So, when you can't trust your own diagnostic tools, your entire debugging workflow basically goes out the window, right? A diagnostic tool has to be your single source of truth. Look at this interface. Users were staring at their system diagnostics and being told that their Tracy or Whoops libraries were not installed, even though those libraries were actively handling events. The tool was literally answering the wrong question, checking a legacy status variable, instead of looking at the actual runtime reality.
Imagine how incredibly frustrating that is. You just spun up a fresh module, everything is healthy, and instantly, boom, a red flag waves claiming your handler drifted. And this wasn't just a fluke. Healthy sites were getting this mismatch warning universally because of how the underlying checks were built.
Which brings us to Section 2. What is handler drift? Before we can fix the bug, we kind of need to understand the suspect. Think of handler drift like a bouncer at a club. The system expects one specific bouncer at the door based on the schedule, but when you walk up, a completely different person is checking IDs. Error handler drift is that exact state where your expected module configuration totally misaligns with the actual library capturing events down at the PHP runtime level. The system expects one thing, but PHP is doing another.
So why does this drift occur? Let's look at Section 3, the naming mismatch bug.
This was our first culprit. It wasn't some crazy race condition. It was just a simple semantic error. The system was comparing the detected library name, like Whoops or Tracy, directly against the declared module directory name, which were XWhoops and XTracy. The tool is basically asking, hey, does Whoops equal XWhoops? Obviously no, they're never going to match. And that guaranteed a false positive on every single healthy installation.
But there was a second, deeper cause. Section 4, aggressive error grabbing.
This really gets to the core of why the handlers were drifting out of sync. In PHP, you have three main handlers: the exception handler, the shutdown handler, and the error handler. By design, an external library like Whoops or Tracy is only supposed to take over the exception and shutdown handlers. It's supposed to leave the core system alone to manage that standard error handler.
But Whoops was getting a bit too aggressive. It quietly hijacked PHP's error handler completely because it grabbed that third handler when it shouldn't have. Even a tiny, harmless notice during the system boot sequence would trigger Whoops to just hijack the entire page load and throw up an error screen. It forced the system into a functional state of drift.
Okay, how do we fix it? Enter Section 5, the provider seam solution.
This is where the architecture really steps up, culminating in the fix for XOOPS 2.7.3. It's a satisfying three-step process. Step 1, normalize those spellings so Hoops maps to XHoops, semantic bug solved. Step 2 is a real game changer, publishing explicit ownership via a provider seam. The system now uses constants to declare exactly who owns the arrow screen. And Step 3, it finally recognizes divided ownership, like when a module handles exceptions but the core keeps errors, as an intentional, healthy agreement rather than drift.
Because of this clean reporting logic, the diagnostic row now reads the true owner token as its value. You can see how informational states like core or dormant mean you're in a perfectly healthy state with no custom provider. On the flip side, states like unclaimed or contested get flagged for review. So if two modules are fighting for control or one silently fails, it is now explicitly visible to you.
Which leads us to our final section, restoring the honest contract. With the mechanics fixed, order is completely restored. We're moving away from a wild west of modules fighting for control to a civilized, predictable ecosystem. Now, two totally independent implementations, like XWhoops and XTracy, can exist alongside each other beautifully.
They only take PHP's handlers when the core has explicitly declared them the owner. They gracefully claim what they need, report their outcome, and leave everything else to the core.
I really love this quote from Mumba because it perfectly summarizes the philosophy here. By introducing that provider seam, the system stopped hard-coding checks for specific tools. Explicitly separating these runtime responsibilities creates a much more predictable software architecture. It's an honest contract that any error provider can hook into seamlessly. So, I'll leave you with this final thought to chew on as you review your own application's error handling. Are your alerts genuinely reflecting reality, or are they just messy artifacts of mismatched expectations? Figuring out the difference is absolutely crucial to maintaining a healthy system. Thanks so much for joining me on this explainer, and I hope this helps you build some truly robust architecture in your own projects.